Hello everyone. So as per all of your request, now let us see some important points of the theory of sets and then we shall go to the problems, right? Okay. So the very basic and first definition is what is called set. See, yes, it's very clear that you all might have known the definition of sets, right? What is the definition of sets? Yes, set means it's a collection of well-defined objects, right? See, collection of objects, it's fine, it's a group of something, it's a group of some toys, or it may be a group of some fruits, it may be a group of some numbers, right? That's fine. But what is called collection of well-defined objects? Here is made the distinction of the statement. What's called collection of well-defined? Okay, see, in books we might have seen A be the set, say A has a set bracket 1, 2, 3, right, like this, and say A may be some other set, let us say this is B, yeah, it's a collection of X such that X is greater than or equal to 2 and X is a natural number, like this we might have seen. Yes, it's a group of some elements, fine, but what is called well-defined object? Let me give you an example. Say, let A be the set, it's a collection of apples, fine. Yeah. Now, will a green apple belong to that set or not? Okay, so what's your answer? Yeah, a green apple belong to that set. Why? Because my statement says that A has all apples, that's all. A green apple, yes, of course it's an apple, so it belongs to that set, fine. Okay. The next question is, will an orange fruit belong to that set or not? Will it belong or not? Is no, because our collection is, it's a collection of all apples, but I have taken an orange fruit. Will it belong to that set or not? No, because it doesn't satisfy the definition. It is not an apple. So of course orange will not belong to that set, fine. So when I make a question, the answer is true to all of you from all your perspective, right? Orange doesn't belong to that set. Yes, this is the statement, everyone's understanding. There is no ambiguity. Let me give another example. Let A be my set that it has all good students of our classroom, right? So now my question is, say whether Raju will belong to this set or not. See, Raju may be a good boy from my perspective and he may not be a good boy from someone's perspective, right? So I will say yes, Raju belong to our set A, but he may say that Raju doesn't belong to that our set, right? So here the answer changes from each one's perspective. The answer is not unique because there is an ambiguity. There is no proper definition for what do we mean by good student. What do we mean by good student? We don't have any specific parameter to that, right? So this definition has some ambiguity. From my perspective, he may belong to that set. From his perspective, he may not belong to that set, right? But the previous example, will orange belong to our set or not, means everyone said yes, no, I'm sorry, everyone said no, right? So there was no ambiguity, but in this statement there is an ambiguity. Yes, this is called well-defined statement. So when we make a statement, there should not be any ambiguity. See, let us see here, see A is a set which has an elements 1, 2, 3. So whether 1 belong to this set or not, everyone says yes. Will 4 belong to this set or not? Everyone says no. So this is a well-defined collection, right? Of course, this is to the same one. B is a collection of all X. X is greater than or equal to 2 and X belongs to a natural number. Will 4 belong to this set or not? Yes, because our 4 is greater than or equal to 2 and our 4 is a natural number. Will minus 2 belong to this set or not? No, everyone says no because minus 2 is not greater than or equal to 2 and minus 2 is not a natural number, fine. So now it's your duty to go and find many examples for which are sets and which are not sets. Just find an examples and send to us, let us discuss. Thank you.